Welcome back, Physics 30. This is the final part of the Part 3 Unit D booklet, Unit 1D booklet. So here we're looking at instantaneous. What are the velocities at each of these following times? Show how you would determine this on the graph. So I have final answers here. To see how we got these final answers, we need to look at the process. So at 3 seconds, 6.5 seconds, and 11 seconds. So first of all, at 3 seconds, 3 seconds is right here on your graph. So it's just 1 point on the graph. So what I do here is slightly to the right of that dot and slightly to the left. I kind of visualize what the slope would look like there. So you can see it's kind of angling up at a steep angle. So next, get a ruler and try to match up what the slope would be at that point. So something very similar to that. And then once I think I have the slope right, just draw a line here, extending it in every direction. And then from there, pick 2 points on that graph. Points that are relatively easy to read on your graph paper. Okay? So once you pick those 2 points, then it's just a matter of figuring out d2 minus d1 over t2 minus t1. So everyone will have a slightly different answer, but it should be very close to each other, depending upon what points you pick. So I'll have you work through that, and I'm going to want to see your work, and you should get around plus 2.8 meters per second. If you get something really off, please ask me what happened, and I'll try to figure out what went wrong on your graph paper. At 6.5 seconds, so if I look back at the graph here at 6.5 seconds, that's around right here going up. So 6.5 is about right there, and you can see I kind of made this green line here, kind of magnifying what the slope would look like. So at that point, go slightly to the right, slightly to the left, and kind of make a very small line there indicating what the slope would look like approximately. And then take your ruler and try to orientate it to match up with that slope. So kind of like that. And then draw a line right through that point in question at 6.5. Then again, find 2 points in this line, d2 minus d1 over t2 minus t1. You can see that the slope up here is going to be a little bit less steep than the slope down here, so we should get a smaller answer. I got around plus 1.0 meters per second. So again, if you're really off from there, come and talk to me and we'll see what went wrong there. Lastly, at 11 seconds. 11 seconds is somewhere over here. So let's see, moving up, it's right there. So slightly on either direction of that point, you can see the slope is kind of moving in this direction. So if I get the ruler there and try to match it up, and then the line I drew is this dotted green one. Then pick 2 points on there, figure out d2 minus d1 over t2 minus t1. Obviously it's going to be a negative slope in this case. And I got somewhere along the lines of minus 0.9 meters per second. So again, you should get something relatively close to that. If it's not quite, make sure you ask me to come over and take a look at it. Okay, so that's how you figure out the instantaneous velocity, the velocity at a particular point. It's not simply finding the point and taking the d over t value. You have to actually figure out the slope of a tangent line going through that point. Okay. Lastly here, just the vocab here for instantaneous speed, instantaneous velocity. So this, if we're simply looking at a value, the speed at a specific clock reading for both of them, or the velocity at a specific clock reading, or if we're looking at a graph, the slope of the tangent line on a distance time graph, or the slope of a tangent line on the position time graph. So once again, whatever point you're looking at, you're trying to maximize the slope by taking a ruler and kind of visualizing, extending it in both directions what the slope of that line would look like, and drawing that line. Okay, so that's it. That's the third booklet for the speed velocity section. Be sure you ask me any questions, especially the tangent line part, because it's a little bit tricky. Be sure to ask me if you have any questions or concerns about that. Okay, see you next time.